Hello guys, welcome to my channel Techmon.in. In this particular video, we will learn how to get the frequency of words using RDDs. So RDDs stand for Resilient Distributive Datasets, and they are available in Pyspark and Scala, all those libraries, okay, all those languages. So for this particular task, I'm going to use sentiment labeled sentences dataset, which is from UCI machine learning repository. Okay, so this data set contains sentence and its score, and score is either 1, which represents positive sentiment, or 0, which represent negative sentiment. Okay, so I've already downloaded the dataset here. So let's quickly look at it. So we have three files. We have data from my Amazon, we have from IMDb, movie reviews basically, and then Yelp from restaurant chain and all that. So we are going to use one of the file only, but let's look at the data. So here is our sentence, and then it is separated by a tab, and then we have our labels. So this sentence is negative, that's why it has a label 0. Okay, and this one is positive, good case, excellent value, definitely. This one is also positive, great for the job home. Okay, so I've already extracted the data in my working directory, so Amazon sells label data, and this is a framework what we are going to learn. So I'll quickly walk you through. So definitely we are going to learn how to get the frequency of words using RDDs. Here we will load the data set, then we are going to split each record, basically separate the sentence and labels. Then we'll create our pack of words, or a long list of words using flatMaps. Then we are going to group by words and finally get their frequency using reduceByKey. Okay, and finally we'll sort the records by frequency, but we can also see how we can sort them by words itself. Okay, so let's jump right on it. So first I've imported the library function add from operator package. Okay, what it does, let me quickly show you. For example, you pass in two numbers, let's say 1 and 2, and when I execute it, returns its sum. Okay, so this package we are going to use when we are adding up the frequencies of the words. Okay, so I'll explain how we are going to use it later. Now here I'm initializing my Spark session. So I've already imported Spark session from Pyspark.sql, and this is pretty much standard format how to initialize your Spark session. Then I've already mentioned here the link of the dataset, which I just walked you through. So this is the link of the dataset for the reference. Then here we are going to load the data. So I've already passed in the full path of my dataset, Amazon sales label dataset. So it always starts with file colons, and then you can see there are 1 2 3 4 backslashes. Okay, so that's how it starts. So I'm using WSL with Ubuntu, so that's why it is like mount and so on. But if you are completely on Windows, so your path will be like 4 slashes this thing, and then E drive and so on. Okay, so something like that. Okay, so I've mentioned the path here. Now what I'm going to do, so these are reviews data, so I'm going to use let me execute this quickly. So as you can see, Spark session has executed local start. This means it will use all the cores present on my system. Okay, so that's why it will be faster. So SC Spark context, here we are defining Spark context. So SC dot, there is a function text file there using which we'll be loading our text file, which is on this path. Okay, so that's how we load the file, and then take a function using this. We can get top n number of records, or not top, just n number of records. Okay, so take 5 means it will return 5 records from the entire data set. Okay, so if I do it top 2, it not top, sorry, I don't know why it's coming up again and again, but it just returns 2 records. Okay, so here it returns 2 records from the entire data set. Okay, then we are going to split each record using map. So map is another function available to us, and by splitting means we'll separate out a sentence from its label. Okay, so I will show you two ways to do that process. So first one, I will declare a function which takes a line, the line which is this one line here. Okay, as input. Okay, so it is taking that line as input. Then what we are going, we are going to split our line using line dot split. So we know that our labels and sentences are can be split using forward slash t tab space. And once I do split on this, what it will do, let me quickly show you that as well. I'm So I copied my text here. Then I will call split dot split forward slash t. As you can see, now it will return as a list. First one is sentence and another part is the label. Okay, so I'm going to assign sent and label. So whatever it is returning, since it is returning two values, first value will get assigned to sent variable, and the second value will be assigned to label. Okay, so we are just going to return sent and label. Okay, so that's all we are going to do for this preprocessor. We could do a lot of things when we are working with text data, and let's say we have to get the sentiment, train our classifier on classifying whether a sentence is positive or negative, has positive or negative sentiments. Then we do a lot of pre-processing, like cleaning the data. As you can see, there is S capital here. It's looks pretty neat, but there could be a lot of pre-processing to do. Like there are verbs with ing, you will convert them to the root verb and so on. Okay, so that's why this is one way you can define a function and write all your pre-processing step there. Then we will say sent label data. So we are going to declare new variable in which I'll be using reviews data here, call my map function, and I will just pass this preprocessor to this. So what will this do? Map function will call each record one by one, each line one by one, and it will pass each line to this preprocessor here. Preprocessor will split the line and return sentences and labels separately, and map will put it together in a in a memory. Okay, in data at backend. So take 5 again. I'm just displaying top 5 records, or 5 records. So as you can see here now, earlier what was the output here? We were getting one a long line. Okay, now we have each value is a tuple. First is the sentence, second is the label. Okay, so that's one way to do it. Another way, if your pre-processing step is not very long, it is just splitting the line just like we did here. We can do it in one line, just like we use def to define a function. We also here we are going to use anonymous function, and we can declare it using our lambda functions. So lambda, I'm writing lambda just like we use def for defining functions. Then I'm here we mentioned what input it takes. It takes one input, and the name of the variable is line. So lambda function here, it will also take one input. Okay, and that input's name is, or that's variable name is line. Okay, then what we did next is we simply just splitted the line on this tab character, and that's all. We are just returning that. Okay, so let's quickly take that. Let me call it sentiment data 2 so that you know the difference. Okay, it has the same output as the above, but in lambda functions, using lambda functions, we can write very simple operations. But if you have multi-line or very long pre-processing functions and all that, then it's better you define a function and then pass that function in the map. Okay, so now we have done one step. Okay, we have separated out sentence from label. Next, we what we are going to do, we are also going to create our bag of words. Basically, we will split each sentence into words. So again, we can do it to very let me show you how we can do it using lambda function first. So it will take a record or row, and at row 0 we have sentence, and at row 1 or at for a at in a particular row at 0th position we have sentence, and at first position we have label. So for row we will pick only 0 or value at 0th index, and we will split it again using space. Okay, so we are saying each word is separated by space, but we can use NLTK package and use its word tokenizer and all that, but that is out of the scope. We are just going to assume that every word is separated by space. Okay, so let me show you the output again. I'll do take 10, let's say 10 this time, and I will pass it in print function. So as you can see, now this was our first sentence here, so there is no way for me to plug in and so on. Now now this has become a list of words in that sentence. Okay, this is another sentence. Great, uh, great for the job on this one. Okay, so these are all the sentence. Good case, excellent value, this one. Okay, so we have split it them. Okay, next what we are going to do, we have to flatten this list. So right now it is list inside list. There is one bigger list here, and then we have sub list inside it, but we want a no list inside list, no nested list. We just want a one big list where we just have the words. Okay, we can achieve it using flat maps. Okay, so flat map, we will write flat map. Okay, where M is capital, F is small. Okay, what we pass inside it, we'll come to that later. Okay, right now let me just call it. Okay, just to show what we are doing, print dot take, let me show 50 words. So as you can see right now, earlier it was a big list outside, and then we had separate list here. Okay, but now we just have a one big list, and we have values, just words inside it. So this one till converter, as you can see, this was our first sentence, so there is no way for me to plug it in here is here in the US unless I go by a converter. Okay, so as you can see, and from here we had a second sentence which you saw here, good case, excellent value. Okay, so this is the second, and so on. Okay, now we flattened it. Now what it takes, flatmap assumes or asks for a function or a lambda function or just some pre-processing step to apply on the data before it flattens it. Okay, so now what we can do is we can merge these two steps together. We don't need two steps. Okay, we are just going to create bag of words too. Right now, first I'll use our label sentence label dataset, which was this. Okay, and then I'm directly going to call flatMap on top of it. Okay, and now what we passed in this map function, right, to split each sentence by spaces, we are just going to copy it and pass it inside this flat map. So what flat map will does, it will take each record here. Okay, it will pick the first value or the value at the first index, split it by space. Okay, split it by space, and then it will internally it will create this data set like this. Okay, once it has created data set like this internally, it will just flatten this list and put words in only one big list. Okay, so we can merge these two operations into one single statement. So let me do print take 50. Okay, so as you can see, now we have the exact same output, plug the jiggle to have. So these I have to jiggle the plug and so on. But earlier we were making use of two steps. Basically now it is in a single step. Okay, now we have solved most of the problem. Now we only have to group by the words and get the frequencies, or basically their frequencies. Now there is one more step required. Okay, which is bag of words 2. I will not be creating another. I will just apply it on it. So right now it is just words, right? But how many times this word is appearing, we don't know in the entire data. But if we look at this, just this word, okay, not these other words or other words in the list, we are just saying this word has appeared one time, this is one, this is one, and so on. And there could be another is let me search, there should be, as you can see, we will assign it one also, it will assign one. Let me show you how we are going to produce, then it will be much better. So bag of words with frequency. Okay, so we will first create, again I'm going to use lambda function, lambda, and here we have each unit or each value is just a word. So I'm saying lambda will take a word and it will convert it into a tuple where first value is word itself and second we are assigning it just one, basically it's a unit, right? We are assigning it. So take let me take 10 only this time. Okay, so we are just saying so has appeared one time, there has appeared one time, and so on, but that does not mean we are limiting to that. So as we were seeing for is, now this is here as well, we have just assigned one along with it, and we also have assigned one with this is. So next what we are going to do, we are going to group by the words, these words here, and then we'll just add up these ones together. So if is has appeared 10 times, so each is will have one along with it, right? So we are going to add up all those ones and it will tell us that the frequency of is was 10. Okay, so how we are going to do that? Word frequency, let's call the so next we are going to use this data set here, and we are just going to call our reduce by key. What does key mean? So each inside this big list, this is one value or one record, you can say this is another record, and so on. Okay, and each record we have two value, this is at 0 index and this is at first index. Okay, so reduce by key, whenever there are some functions like by key, they assumes that your first value in a record is your key and other values are value. So just like in Python we have dictionaries like this. In dictionary we have key and its value 1, b, let's say, and its value 3. Okay, so let me assign it to d. So this is one dictionary. Okay, so if I call d dot keys, okay, and print d dot values, let's see what's the output of it. So for it in this dictionary, for these a and b, these are the keys, okay, and the values are 1 and 3. Similarly, it assumes the Pyspark assumes RDDs assume that's how it is written, right? The first value in the tuple is key and rest are house value. Okay, so reduce by keys, it is going to group by the keys first value, like is, it will combine all the words by their first value. So all the is will be together, all the so's will be together, and so on. Okay, and once it is when it's done with bringing all the is, goods, so's, and so on all the together, what it will do, it will do some operation on it, and we will tell what operation to do. So we are telling it to add them up. So once it brings this is and this is together, okay, these two is together, we are telling to add its values. So we are telling it to add these ones together, and that's how we are going to get the frequencies. Okay, so let me take 10, hopefully the is also appears. So as you can see, so there the word there has appeared 11 times, is has appeared 238 times, and converter, this has appeared only one time, and so on. So good has appeared 13 times. So now we got the frequency. So I'll say again, first value in each record. For example, if we had called on this sentence, this data here, okay, so here also we have this is one record and its first value is this entire sentence. Okay, and this second value is the you can say value. Okay, key value pair. So this becomes the key, this becomes the value, just like we saw here in this example, right? So it summed up, brought all the keys together and then just summed up their values together. Okay, so that's the purpose. Now we got this big list. Okay, I can also do 50, or let me do not. So this is but it won't be done. So let me add print. So as you can see, we have these all the words, but now they are, as you can see, this is 11, this is 238. They are just in random fashion. There is nothing like ordering, neither by words nor by their frequency. Okay, now we are going to sort them. We are calling it ordered. Now we are going to use two sort bys. First, let's use sort by key. Okay, as you can see here also, we have each this tuple here is a record, and sort by key means it will sort the data by the key, basically the first value in the tuple. So first let's just output the result of this. So as you can see, maybe I'll have to print more. So yeah, let me print top 50. Oh, my bad. Okay, so as you can see here, it just sorted them, this exclamation mark based on sky value. It is comparatively lower than these values, so that's why it has appeared. But as you can see, the data, we didn't clean it much, so that's why we are seeing such values. But definitely they have been ordered based on the first values. Okay, now if we have to sort based on the not based on the key but based on the value, here we will use another function. Okay, let me show you. Instead of sort by key, we are going to use sort. Also, before coming to that, we have ascending equal to false. So right now we were doing in ascending order. By setting ascending is false, we'll be doing in non-increasing order. Okay, so as you can see, Z, you know, as the last letter in English alphabet, so it has appeared at the last, and so on. Then Y's and so on, then W's and so on. Okay, so using this we can either do in ascending or descending orders. Okay, let me print it. Similarly, now we are not telling it to sort by the key first value in the tuple, but we are going to tell the RDDs which value to pick. So we are saying lambda will take each row. Each row is the meaning each tuple it will take, and then we are going to tell which value to sort the data based on. So we are going to tell first. So the index of 0 is this first value is at index 0, then this is at index 1. We are saying sort based on index 1 values and not by index 0 values. Okay, and also let's say ascend. Let me copy it, it will be much faster. Ascending equal to false. So these are the most frequent words in our data set. So the has appeared 414 times, over 400 times, then followed by and, then I, and so on, you can see. Okay, and let's also get by inverse. So converter was like only one time, jaw was jaw appeared one time, and so on. These are all the ones, these all appeared one time only. Okay, now we learned about sort by key. Using sort by, we can also apply you know, mimic the function of the we can also sort by zero values keys. Here, if I pass index as 0, it will automatically sort by the first value, which is which is the words, or we can call it which is the key. So as you can see, now we have the same outputs. So if we are going to sort based on the first value of the tuple, it's better to use sort by key. Then we don't have to write such lambda function. But if we have to sort based on any other value, based on any value other than key value or the first value, then we can mention it here, just like we did below. Okay, we already did it like this. Okay, so that is all for this video. I will be coming up with more applications either by RDDs or Pyspark, and will be adding up those. So hopefully you are enjoying my videos, and definitely you are finding them valuable. Please let me know in comments if you have any question to clarify and all that. Okay, thank you so much. Bye bye.